from our last unit. So just at the top, just says factor. I've just got x squared minus 6x minus 27. So just plain quadratic. Somebody tell me the factors for if I had x squared minus 6x minus 27? Yeah. Yes, good. So one's a x minus 9, one's an x plus 3. Excuse me. Multiply to get negative 27, add to get negative 6. That's it. That's all you have to do. All right. Now, the one in the middle, I got 3x squared plus 6x minus 45. What would you maybe do first on that question? Yeah. Okay, now, if we have an equation, we can get rid of the 3. If we're just factoring, I just need to, it's like undoing a distributive property. So I'm going to pull a 3 out in front. So if I'm just factoring, I have no equal sign, no equation. I can't get rid of the 3. I need to see the 3 in the factors. And then left over, we'd have x squared plus 2x minus 15, just dividing each term there by 3. So I got to leave the 3 out in the front. And then I want to see if I've got factors for what I have inside the parentheses. Perfect. Multiply to get negative 15, add to get 2. One is x plus 5, one is x minus 3. Does not matter the order you put those in. You could put the x minus 3 first, the x plus 5 second. It doesn't matter. Does anybody remember how to factor the x squared minus 49? It's called a difference of squares. Do you remember?
Plus or minus 7.
Plus or minus 7. Okay, so just one is an x plus 7, one is an x minus 7. Again, it completely doesn't matter the order as long as you have one of each. Is anybody having a question? Okay, if you can do that, you can do what we're going to do today. So if you look at each of these questions here, they're almost identical to what's above, but I've got different powers of x is what's going on here. So this one says x to the 4th. This is called quartic. X to the 4th power is called a quartic polynomial. Minus 6x squared minus 27. So my constant is still negative 27. My middle term is now a quadratic term. It's x squared. Anybody know? It's very similar to what we just did above. Anybody have any idea how you would factor if it's to the 4th power instead of second?
X squared minus 9, x squared plus 3.
Yes. Okay. It's literally identical, but if I got to take and FOIL two things together to get x to the 4th, you're just going to use x squared. So it's the exact same factors except for it's x squared instead of a plain x. Otherwise, the factoring works the same way as a quadratic. If you multiply that back out, x squared times x squared give you the x to the 4th. And the middle terms, you'll have x squared times 3, and then x squared times negative 9. That'll give you the negative 6x squared. And you still have the plain number, negative 9 times 3. That'll give you the negative 27. Okay, now, this does say in the directions, completely factor. I don't have an equation here. So I just want to ask you, can I take either one of those factors and break them down farther than what I already have? What could I do there? Okay.
Negative 9.
So how would you break that down further?
Oh, x plus or minus 3i. Oh, wait.
Just factoring. We're not solving anything. No I.
Oh, x plus or minus 3.
Yeah, okay, so just this right here is the difference of squares. So just a x plus 3, x minus 3. Now, the x squared plus 3, we're just going to leave that alone. That's not a difference of squares. That's actually two things added together. But this x squared minus 9 can be further factored into x plus 3, x minus 3. Okay, anybody having a question about that? So that might happen if you have an x to the 4th. You might be able to take one of your factors and go a little bit farther with it if it's a difference of squares. Okay, now, otherwise, these are going to look identical to what you have above. We're just going to use an x squared instead of an x. So this one, I would still take a 3 out in front, and I would still need that because I don't have an equal sign, so I can't just get rid of it. I have to pull it out in front. But this would just be x squared plus 5 and x squared minus 3. It's the only difference between factoring a quadratic and factoring a quartic in this format is just the squared. That's it. All right, and then this guy in the end, this would just be, one would be x squared plus 7, the other would be x squared minus 7. And we're going to use factoring to to help us solve some polynomial equations that are going to be kind of lined up in this format today. So just in general, got a little summary, and we talked about some of this stuff yesterday. Just as the number of solutions. Okay, solutions would also be zeros or roots or answers. All those words are kind of interchangeable. So solutions are what makes the equation equal to 0. And so the number of solutions is going to be equal to the degree of the polynomial. Now, to determine the degree, it's super easy. It's just the highest power of x of your polynomial. So if you've got your polynomial, everything's in standard form. Whatever the highest power of x is, that's how many answers or zeros or roots or whatever you want to call them. That's how many you're going to have for that polynomial equation. All right, this says, if the solutions are real, we're not going to graph anything today, we're going to do that tomorrow, but it says if the solutions are real, they can actually be seen on the graph, and where that will be is where the graph crosses your x-axis or your x-intercepts. So if you have a graph of a polynomial, if it has real answers, you can actually physically see it where it crosses or touches the x-axis, x-intercepts. Now, we saw this a little bit yesterday. Each of the questions we had at least 2 imaginary solutions. This is going to say if the solutions are imaginary, so they have an I in them, you wouldn't actually be able to see that on a graph, so you would have to use algebra to solve for that. And sometimes that might be quadratic formula, sometimes that might be square roots, which is what we're going to get into more today here in a second. Now, the one thing you have to try to do if you have a polynomial is try to factor it as much as you can. This says in this next little step, if all the factors of the polynomial, if we try to put it in factored form, are not linear. Okay, linear would be a factor, be super easy, like if we have, like x plus 5 would be a linear factor, or something like x minus 2. Those are super easy for you to tell me the 0, because you just tell me what you plug in for x, and then we know the answer for the polynomial if that's one of the factors. If they're not linear, you got to at least try to get them down to quadratic factors. And if you have quadratic factors, like we had that yesterday with our sum and difference of cubes, we could use the quadratic formula, or what you're going to see that we're going to mostly focus on today, you can either use the quadratic formula, or today we are going to solve almost all of these using square roots. And that'll make more sense hopefully in a second when we start to solve some of these equations. Okay, now these, again, these are the same 3 problems I've had like top down here. So the difference is I have an actual equation here. So I just want to show you guys how to solve these. Before I do that, how many solutions should I have if I'm working with x to the 4th minus 6x squared minus 27? Oh, you're just telling me with this hand. Should be 4 answers here. Okay, 4 answers. So keep that in mind. If I've already factored this, which we've done above, and I'm just going to start with that first factored form we had. I had x squared minus 9, and I had x squared plus 3. The difference here is that is set equal to 0. Okay, now, if you want to go ahead, and you notice this is a difference of squares, if you want to go ahead and write that x minus 3, x plus 3, and the other one doesn't break down any further, but 2 of my answers there, I'd get 3 or negative 3, so that's 2 answers right there. To get my other 2 answers, in this case, I got 3 things to multiply together to get 0. Any one of those, if there's 0, it's going to wipe out the whole thing. For this, if x squared plus 3 was equal to 0, that would actually give me an answer to this question as well. I'm just going to literally solve this little bitty, just subtract 3 here. So I get x squared equals negative 3. Now I got to take a square root there to get the x by itself. And when I do that, remember, if you introduce the square root, that generates that plus and minus symbol. So that's actually going to give me 2 more answers. So I'm supposed to have 4 total, right? So I've got the 3, the negative 3, and then I'm going to get 2 more answers here because of my plus or minus. What would you write down for square root of negative 3 to simplify that? I square root of 3. Perfect. So just I radical 3. We wouldn't be able to see those solutions on a graph because they're imaginary, but they are 2 answers. If you plug that in for x, that would make that equation equal to 0. Does anybody have a question? Okay. So let me do this one here. Now, this is different than the problem above. If I have a greatest common factor, numbers only, don't do this with variables. Certain people, just kidding. Just don't do it with x. Okay, you can't get rid of you couldn't do it for this question anyway because the 45 doesn't have a variable, but just you can get rid of numbers if you want to. I'm not trying to call people out, I'm not mean. All right. So this would be plus 2x squared and then minus 15, all right? Which we've already factored above, but what I'm showing you here, you can actually just get rid of that 3, so you're not even working with it. And this factored into x squared plus 5 and x squared minus 3. Now, in this case, just 2 things multiplied together to give me 0. Sorry, I should have written this at the top. This one should also have 4 answers because I have 3x to the 4th. So that 4th power is what's going to tell me how many answers I have. So 4 answers here. And these are both, if you want to just set these equal to 0, be in that like plus or minus format. If this makes sense to you, you don't have to write out a bunch of work here, okay? I know I'm going to subtract 5, and I know I'm going to take square root of negative 5 there. If you're taking a square root of a negative, just don't forget that's imaginary. So just plus or minus I radical 5, that's actually 2 answers. So I've got 2 of the 4. And here I would actually have adding 3. So this would be x squared equals positive 3. If we were to graph, set this equal to 0, how it is, if I replace the 0 with a y and we graph this, you would be able to see plus or minus square root of 3 on the graph. That's a real answer. It would cross the graph in 2 spots. If you were looking at Desmos, it would not tell you like this is a square root of 3 and give you some gross decimal for that. But there would be 2 real solutions here, 2 imaginary for this question. You guys got a question? Okay, yeah, you are kind of yelling. Okay. X squared minus 7, x squared plus 7. We've already factored this. Can't do anything else there. Here I would add 7 and take the square root. So right here you'd have plus or minus square root of 7. Here you would subtract 7 and take the square root. I'm not on the screen, sorry. You would subtract 7. So if you're going to subtract 7 and take a square root, you're going to get an imaginary answer. This would be plus or minus I radical 7. You're welcome to write it out, or if that's making sense to you and you want to save some time, you can just go ahead and write those answers there. Is anybody having a question? Okay, now I'm just going to give you 2 more problems, and these are going to be like from scratch. We haven't been talking about these problems all day and already factored some of this stuff, so we're going to factor these from scratch. Okay, so just remember if you got x to the 4th, right? This is going to be 4 answers. And that's going to be true for both of these questions because they both have x to the 4th. So I should have 4 answers for each of these questions. Okay, so if you got this format, you got to the 4th power, then something squared, then a plain number, your constant term. It's going to factor like a quadratic. But what you've got to remember is you want to start each of those factors off with x squared. Okay, now, can you guys think of 2 numbers? If you multiplied them, you'd get negative 32. Add them, you'd get 4. What do you think? Yes, yes. Okay, I had to think about that way too long. Okay, one of them's a plus 8, one's a minus 4. Multiply 8 times negative 4, you get negative 32. 8 minus 4 is going to give you positive 4 there. Okay, now, I'm just going to show you this real quick. Right now, if you want to, we can just solve by using square roots. So this would be x squared plus 8 equals 0. I'd subtract 8. Now this one's a little trickier than some of the ones we did on the front because when I take a square root here, like square root of 5, 5 doesn't break down under a square root, but 8 can be broken down under a square root. So I'm going to try and write this in simplest radical form. So it's still going to be plus or minus because I'm taking a square root. I introduce that. I get 2 answers out of this, out of my total 4. Now, however you guys want to do this, factor tree or my fave is the biggest perfect square. So I would just think about that as 4 is the biggest perfect square that would go into 8. So I would just rewrite that real quick in my mind as -4 times 2. -4 is, bless you, perfect square in imaginary land. So this would come out as 2i, and a 2 would be left under the radical. So this would look like 2i radical 2. We would not be able to see these on a graph. Okay, now if you notice this was a difference of squares and you wanted to break it down to x minus 2, x plus 2, you could do that. If you didn't, if you're solving, it doesn't matter. I could just do x squared minus 4 equals 0. Add 4 there, take square root, and I still get plus or minus 2, even if I didn't notice that that was a difference of squares. Now, if I'm being told to completely factor something, I'd have to pay attention. But if I'm just solving that, I can just set that equal to 0, add 4, take the square root. And there's 4 total answers there. Okay, anybody have any questions? Can anybody factor x to the 4th minus 81 for me to help me get this last question solved? How would you factor x to the 4th minus 81?
X squared plus 9, x squared minus 9.
Yes, okay. X squared plus 9, x squared minus 9. Again, if you notice that this is a difference of squares, you could break that down further. If you don't, it doesn't matter. We're just trying to solve this. Just set this equal to 0, set this equal to 0. Okay, now if I have x squared plus 9, and that's equal to 0, if I do this correctly, I would start by subtracting 9 from both sides. So I'm going to take a square root of a negative, so that's going to involve an I. What's the square root of negative 9? 3i. This is a perfect square in imaginary land. So plus or minus 3i. I don't have to break that radical down. That's a perfect square. It's just going to be 3i. Okay, now the other one, again, if you notice this, this would be x minus 3, x plus 3, difference of squares. So you'd get 3 and negative 3. Or if you don't notice that, you can just actually do x squared minus 9, set that equal to 0, add 9, and you'll still get, when you take the square root, plus or minus 3 for your 4 total answers. So plus or minus 3i and then plus or minus 3. Is anybody having a question? Okay, now the rest of what we're going to do is actually just a little bit more with imaginary numbers here. All right, you can actually factor each of these questions in example 3, but using imaginary numbers. And I've got x squared plus, okay, so not a difference of squares, x squared plus 36. Anybody know how I could factor that? Like, what would the 2 little sets of parentheses be? These are just quadratic, just a plain x squared. What would you put in there? And these are going to use imaginary numbers. I got x squared plus 36. How would I fill those factors in? What do you think? Yes, okay, you're just going to use, it's still the square root, but it's going to use an I. So just one of them's plus 6i, one of them's minus 6i. If you're like, what the heck is that? This is the actual answer. Let me show you why this works. And you don't have to do this on any questions on the homework or anything, but I'm just going to show you real quick. If I actually FOILed this back out, these are what we call conjugates. We mentioned this before, positive 6i, negative 6i. If you multiply these together, all the imaginary parts are going to cancel. So x times x give you x squared. X times negative 6i, we just write the letters that appear there in alphabetical order. So I would write that as negative 6ix. But because these are conjugates, one's a plus and one's a minus, you're going to turn around and get plus 6ix, and those two things will cancel each other out. Now, the rest of this exists, but it's going to cancel the imaginary part out. So I'm going to have positive 6 times negative 6, which will be negative 36, and then I times I, which becomes I squared. Do you all remember what I squared equals? Negative 1, yes. Okay, so in this term, what I have is x squared minus 36 times negative 1. So the imaginary parts all cancel out. That last term, negative times a negative, that turns that back into what we started out with, which was x squared plus 36. So difference of squares, you're going to have real answers. If I have plus in between 2 squares, you're going to have 2 imaginary, and you can use those to help you factor. So If I asked you, how could I factor x squared plus 9? What would you write down as your factors for that? Yeah. Exactly. X plus 3i, x minus 3i. I'm not solving anything here. These are not equations. They're just expressions. I'm just asking you to factor it. Okay, now, the last one is really tricky. I have 4x squared plus 25. Anybody know how I would factor that last one? You can factor. You got to use imaginary numbers. How can I factor 4x squared plus 25?
Is it 4x plus 5?
You're on the right track. One of them is going to be plus 5i, and one of them is going to be minus 5i. What should the first term be, though? Not 4x. It's 2x. It's the square root. So I could take the square root of 4, square root of x. This would be 2x plus 5i and 2x minus 5i. And you could switch the order. You could put the minus 5i first, the plus 5i second. Those are both correct. Okay, anybody having a question? Okay, the last thing I'm going to do here. I'm going to give you some answers to a polynomial equation, and we're going to work backwards from the answers to write the polynomial equation. So zeros are the same thing as solutions, roots, answers. These are all, you don't have to write this down. I'm just writing it real quick. I'm giving you the answer. So this question I'm giving you the answer to says one of the answers is 6, and the other two answers are positive and negative 8i. So if I tell you, let's just start with the 6. If I tell you 6 is an answer, could you tell me the factor that would go with that? So 6 is an answer. What would the factor be that would go with 6 being an answer? Not 36. Just 6 by itself, not plus or minus 6. Yes. So this is positive 6. X minus 6 would be the linear factor. That's all. I'm just translating it, just like kind of working backwards. Okay, now the 8i and the negative 8i, same thing. One of them will be minus, and one of them will be a plus. And that's literally it. That's the factored form there. Okay. What if I told you my answers were 0, 3, and then plus or minus 5i? What would the factored form of the polynomial look like for that? Bree, why don't you tell me?
Would it be x and parentheses x minus 3, and then x minus 5i.
Perfect. X minus, and it doesn't matter. We could put these in any order. I would do what she did, though. I would put, if you have 0 as an answer, I would just put a plain x out in front first. That usually makes it easier to do. Okay, now all I'm going to do, I'm using these same examples underneath. I'm just going to have the factored form above, and we're going to write the standard form below. Okay, now my best advice to you. If you have to multiply something like this out, multiply together, like for both of these, multiply together the two terms, or sorry, the two factors that have the imaginary. Like you can, if you're bored, FOIL x minus 6 times x minus 8i, and then FOIL it with the x plus 8i. I'm going to tell you right now, it's going to be really annoying, and you're probably going to screw something up. So multiply these two together first. It will make it so much easier to do. Okay, so I'm just going to write this down here again so I can see it. I'm going to focus on the x minus 8i times the x plus 8i. Whenever you multiply conjugates together, and you saw me do this in example 3 there just a couple seconds ago, the imaginary parts will cancel out. So just doing two at a time. This would be x squared. You get plus 8ix, but then because they're conjugates, you turn around and get minus 8ix. Now the term on the end, you'd have negative 8 times positive 8, so it'd be negative 64, and then I times I becomes I squared. I squared is always equal to negative 1, so these two guys are going to cancel, and you're going to have x squared negative 64 times negative 1 would just be a plus 64. And then I'm just going to bring this guy, this x minus 6, I haven't involved that yet, so I still have to do that if I want to completely multiply this out. And then I just FOIL what I have left. All right, or you can draw a box if you want to draw a box. X times x squared gives me x to the third, which makes sense because I was given 3 answers, so this should be a cubic, so it should be x to the third as my highest power of x here. All right, x times 64 would be 64x, negative 6 times x squared, negative 6x squared, and then negative 6 times 64 is like a little bit bigger number, negative 384. And then a lot of time, not always, but a lot of times when you do these problems, it won't quite be in standard form. I gotta real quick interchange the negative 6x squared and the 64. We just gotta flip them to write that in standard form. And that makes all my powers of x go down in order from greatest to least. Yes, ma'am. What were you going to ask? Oh, I thought you... Go ahead.
I was gonna ask if you had to do all class in or if you could just know that.
If you looked at that and said, I know that's x squared plus 64, go for it. That's fine with me. Yeah, I just want to show you where it comes from. But yeah, if you're looking at that and you go, I know that's supposed to be x squared plus 64, cool. I'm glad that you know that. That's awesome. You can skip that step. All right, so now, I want to tell you one thing on this one. So, and you guys can see it on your paper. I'm just writing it so you guys can see it on the screen. Again, now, Miss Grody looks at this, and Miss Grody goes, okay, I know if I multiply those guys together, those imaginary, that's just going to be x squared plus 25. I just know that because I've been teaching this for way too long. But if you want to multiply it out, that's fine. If you look at that and you're like, I know what that is because I just watched her do that and I know what the pattern is, please go ahead, skip all that work. That's totally fine with me if you understand that. Now, what I do want to tell you here, because people get sometimes tripped up by this, see how I have this x out in front? Okay, sometimes people will accidentally distribute that to both of these sets of parentheses. If you do that, you're really actually multiplying by x twice. So you're really multiplying by x squared. So if you have something like this, my best recommendation to you, I would just real quick, just distribute it to that first set of parentheses that it's right next to. Don't multiply it again. I've already multiplied by that x. Just do 2 things at a time. And then I would bring down that x squared plus 25. And then from there, just FOIL those 2 together. Just make sure you don't distribute that x to both sets of parentheses, because then if you do that, you're really multiplying by x twice, which is multiplying by x squared. So you don't want to do that. This had 4 answers, so I should have x to the 4th. Yeah, you could do it. Yeah, you could do it. You could do like FOIL these 2 and then just distribute it. Yeah, definitely. There's a bunch of different ways to do it, for sure. Just do 2 at a time. That's what I would always tell you. Just do 2 at a time. Okay, this ends up being, that actually might have been smarter to do it that way. This ends up being x to the 4th plus, let's see, 25x squared minus 3x cubed and then minus 75x. And again, just sometimes when you do these, it won't be in standard form when you get done. So I'm just going to make sure I have my powers of x in order. So I got to switch up and write that negative 3x cubed first, 25x squared minus 75x. And this should be x to the 4th because I had 4 answers. So I know I did it right. Is anybody having a question?